Okay. So this means Cody Payne knows the scientific method, because obviously McToon doesn't, guys. We know this. McToon doesn't know what science is, even if it hit him in the face. Cody Payne studying physics, so we'll see.
As some
He
people in
looks
chat
kind
are
of
kind of pointing
nervous.
out, of course, there's not just one scientific method. We all kind of
Yeah.
know that. There are.
No, there's one scientific method. Method means singular,
Yeah.
correct?
Yeah.
So off the
And
bat,
just because that method has more things in it doesn't make it less than one method.
oh man,
That's right.
what's so hard to understand with that? Off the bat, this
Yeah.
Cody Payne physics student already shows he doesn't know what science method is.
The scientific method is just a process or steps taken to produce reliable results to answer a specific question.
The scientific method is a process of experimentation that is used to explore observations and answer questions, or help scientists ensure that the conclusions they draw are accurate and not based on false assumptions.
A better name for this talk might be something like What Flips Get Wrong About the Philosophy of Science, which is what we'll kind of go into.
Sorry. Philosophy of science is not the scientific method.
Remember, the philosopher is the would-be scientist, but without a laboratory, right? And so what happens is the 1920s come in, we learn about the expanding universe in the same decade as we learn about quantum physics, each of which falls so far out of what you can deduce from your armchair that the whole community of philosophers that previously had added materially to the thinking of the physical scientists were rendered essentially obsolete. Philosophy has basically parted ways from the frontier of the physical sciences.
I think that Flat Earth is kind of dead out of the gate when you consider how they think about science, how they go about thinking about confirmation and experiment. And so, honestly, without even touching on scientific facts and observations and experiments in and of themselves, I think we can kind of refute Flat Earth by just showing that they don't even have a leg to stand on from how they're approaching epistemology.
Epistemology? Really? Show me science and epistemology, please.
A couple of really dumb things that the unholy trinity of Nathans say most often that's associated with them is, for example, if you show them an experiment, they'll immediately go, well, what's your IV? What's your DV? What's your CV?
Yeah, that's what an experiment does. If you have an experiment, it means you have a hypothesis, which requires you to have an IV, a DV, and CV.
Remember, a controlled experiment is a scientific test in which all conditions are kept constant except for the variable you're testing. Hi everyone and welcome back to High School Science 101. We're covering our three main variables in science, which are our independent, dependent, and controlled variables. In most science experiments, you will have three variables: the independent variable, dependent variable, and control variables.
And of course, not all experiments have a well-defined independent variable.
What?
How dare you?
What? Did I hear that right?
And of course, not all experiments have a well-defined independent variable.
What?
Not all experiments have a well-defined independent and dependent variable. Then it's not the...
Experiment at
Oh
all.
my word.
So, from the nature of science and the scientific method, a hypothesis. The hypothesis should contain a prediction about its verifiability. For example, if the hypothesis is true, then 1 should happen when 2 is manipulated. The first blank is the dependent variable. It depends on what you are doing in the second blank. And the second blank, number 2, is the independent variable. You manipulate it to get a reaction. There should be no other variables in the experiment that may affect the dependent variable.
This guy is a moron. You don't know science, Cody.
For experimentation.
Yeah, but I mean, you can't do an experiment without having a hypothesis. And your hypothesis clearly states 1, which is which. It's not badly malformed. It is a well-defined structure. This is the cause, aka independent variable IV, for the dependent variable, aka the observed natural phenomena, and this is your control variables to hold constant. That's well defined. You can't have an experiment if your IV and DV is not well defined. How the hell are you going to know what you're doing and what you're observing?
It's
Of course, just a really bad way to look at a scientific experiment is, well, I can't identify an independent variable, then that experiment, just throw it out. It doesn't matter what it says, doesn't matter anything about it.
It's showing he doesn't know what an experiment is. You can't identify independent variable, so just throw it out. No, you testing the independent variable. That's what the flippant scientific method's about, testing it. You observe something in nature, you want to figure out the cause for that observed phenomena, which would mean you make an IV. You predict that is the cause for what you observed. You clearly know what it's defined as. You are testing that cause.
An independent variable, also called the manipulated variable, has the ability to stand alone. It is the variable you are changing or manipulating. In simple terms, you change the independent variable. You will find it on the x-axis.
If it shows to be false, it means that wasn't the cause. If it shows to be true, that means it was the cause.
Or it confirms flat Earth. Like if you want to shine a laser across the Sea of Galilee to confirm flat Earth, you can do that.
That's not science. But okay.
Totally fine. But if it confirms the globe, you can't use man-made apparatus. So, and then finally, a third really dumb one that kind of gets past our just ideas of things.
Yeah. Show that Illuminati sign, why don't you? Very, very comforting.
you remember that.
You're not even going to dignify it with a long discussion. It's, well, if you're not putting your hands on your IV and manipulating it and moving it around with a screwdriver, and that's not a valid experiment. The only way to do an experiment is to have your IV be something that you physically manipulate with your own hands. And of course, that's just not true. And it's not even worth dignifying with a response.
The steps of the scientific method are as follows. Make an observation and ask a question. Conduct research. Form a hypothesis. Test the hypothesis with an experiment. Analyze your data and draw a conclusion. Communicate your results.
And in today's lesson, we are going to be looking at the scientific method. Now, our scientific method is based off of observation. We see something in nature and we want to figure out how it works. So we ask ourselves a question. Why is this happening? When does it happen? And now, in order for us to test that question, we have to come up with a hypothesis. We have to think maybe what is going to happen. We create an experiment, we analyze the results that come from that experiment, and we write a conclusion.
So the fourth thing I have listed here is, first we'll say the cause that you're trying to investigate. What you're trying to say is causing your physical phenomenon. That's one and the same with the independent variable of your experiment.
It is the independent variable. What? What? He says that is the same as the independent variable. That is the bloody independent variable.
Group laugh, everyone. Group laugh.
Inform your hypothesis, which is a prediction of what you believe will occur. It is often seen as an if-then statement and is very specific. Once you know what types of data you're going to collect, you can define the variables in your experiment. There is the independent variable, which is the thing you change to see how it affects your dependent variable, which is the thing you measure.
This guy is a moron. You don't know science, Cody.